Hello again, and welcome to this video on how to draw Lewis diagrams. Now, I like Lewis diagrams way better than I like Bohr diagrams because I get tired of trying to draw neat little circles. And with Lewis diagrams, you're only drawing the electrons in the valence shell or the outside shell. So only the outside or valence electrons are drawn. And I'm going to show you what I mean by that. So in a Bohr model, if we went to draw nitrogen, we would have to draw it. We'd look and see that it has an atom of nitrogen has 7 electrons. So 1, 2, 3, 4, 5, 6, 7. Okay, that's a Bohr diagram. That's what you're used to drawing by now. A Lewis diagram only shows this outside shell. So just the 5 there, 1, 2, 3, 4, 5. Which is why I like it way better. It's much faster to draw. The only tricky part is you have to figure out how many valence electrons there are. So there's a couple ways of doing this. One, you could say, okay, there's 7 electrons, and I know that 2 go in the inside shell, so that makes 5 left over. Or there's a little sneaky trick way. If you look at the top of each column, you see this number like 15, 16, 17. This is the group number. Groups are vertical columns on the periodic table. And the second digit, or the only digit if you go over here, tells you how many valence electrons this atom has. So for example, nitrogen has 5, which you can see from my drawing. Oxygen has 6, fluorine has 7. So that's a kind of a sneaky little shortcut if you can remember it. If not, then you can take away 2 for the inner shell. Once you're getting up to, say, chlorine, where there's 17, you'd have to draw a shell with 2, a shell with 8 to make 10, and there would be 7 left over. So you have to kind of add them up each shell and see what you're left with in the outside shell. So up to you whether you want to do a little bit of addition or just look at the column number, the group number. Up to you. So I'm going to show you both ways for a couple of examples. So here's lithium. Lithium is in group 1, so it has 1 valence electron. You could also think of it as, if we were drawing it as a Bohr model, it would have 3 electrons. So 1, 2, 3. Obviously, if you have to draw a Bohr diagram to draw a Lewis diagram, it's not worth it. Just draw the Bohr one, that's fine. I'll let you draw either or. But I like a Lewis diagram because you would just draw 1 dot, 1 electron. Let's try chlorine without drawing a Bohr model first. So chlorine has 17 electrons. So as we said before, I would have 2 in the inner shell, then 8 in the next shell. So there'd be 7 left in the outside shell because 2 plus 8 is 10. And 17 take away 10 is 7 left. Or you go see that it's in group 17. And you follow the exact same pattern you did with Bohr. So 1, 2, 3, 4, 5, 6, 7. Done. Okay, what about calcium? It's in column 2. So you can draw 2 valence electrons. If you like to add them up, you would say, okay, there's 2. I'm going to write it out because it's getting longer. 2, and then 8 is 10, and then 8 is 18, and I've got 20 electrons, so I have 2 left in the outside shell. 1, 2. So you can see you come up with the same number either way, whether you're looking at the group number or the number of electrons and adding. All right, oxygen. Here it is in group 16, so there's 6 electrons in the outside shell, or if you do 8, take away 2 for the inside shell, you get 6. 1, 2, 3, 4, 5, 6. Okay, so those are my atoms. Should make that clear. Now when you draw ions, it can actually look a little bit confusing because when lithium becomes an ion, you can see that it has a +1 charge, so it loses that 1 electron. So a lithium ion just looks like this. You put charges around it, or brackets around it to show the charge, and it's just 1 plus. So that's it. No electrons required. Something like calcium, where it's going to gain 1 electron, it looks like this. Oh, sorry, I didn't do it in the right pattern that time. I knew it was going to be full, so I cheated. Don't do what I do unless you're very sure. Okay, so it gains an electron, and you put brackets around it and a minus to show that it gained 1 negative electron. What about calcium? What do you think it's going to do just from looking at it? You know it's going to lose those 2 spare electrons. So it just becomes Ca, and it lost 2 electrons, so it's 2 more positive than it was before. Again, you can write +2 or 2 plus. Your periodic table says 2 plus. It's the same, it doesn't matter. Okay, oxygen, what do you think it's going to do? Gain 2, right? 1, 2, 3, 4, 5, 6, 7, 8. And now we do 2 minus, or -2 because of the charge, because it gained 2 negative electrons. Okay, so these are the ions. Now what you might notice is all the non-metal ions don't have any valence electrons anymore. They've given them away. And all the non-metal ions have gained enough electrons to make a full outer shell of 8. So your non-metals always look like this with a full shell. And don't forget this charge. Okay, it's time to practice. So I'm going to get you to pause the video and try drawing phosphorus, magnesium, fluorine, and potassium, both the atom and the ion. Pause the video, grab a scrap piece of paper, and give those a try. Okay, welcome back. I hope that went well. Here are the answers. So phosphorus has 5 electrons in the outer shell and gains 3 electrons when it becomes an ion. Magnesium up here has 2 electrons in the outer shell and loses those 2 when it becomes an ion. Fluorine has 7 and gains 1. Potassium has 1 and loses it to become a positive or cation. So you can see, just like before, my non-metals have a full shell of 8, and my metals have no valence electrons left after they've lost them. Yeah, I hope that's helpful. Go ahead and do some practice questions and come see me in class if you need some more help.